detail and a lot of frustrations about what I see in terms of new graduates coming out into the workforce. And I like to talk about it, and people seem to appreciate it. So let me start out here by asking, who here, is anybody, do we all develop software here? Anybody not develop software? Anybody like sysadmin, DevOps, what do you do?
IT help desk.
Okay, IT help desk.
Mechanical engineer.
Okay, but you're looking to get into software? Hand it back.
PM programmer.
Okay. Those of you who are developers, how many of you would consider yourselves pretty new in the industry? Okay. Oh, wow, excellent. And what is new? Like less than 2 years?
Yes.
2 years? Excellent. Okay, well, I'm glad to hear it. How many here will not raise their hand for any question I ask? Okay. Come on, clicker. So, why are you here? Anybody?
To learn.
Sorry?
To learn.
To learn? What, are you, anything you're expecting? Yes.
I'm transitioning from help desk network support into software development.
Okay. And so, anybody else? Okay.
Pardon me, I'm just getting out of college, and it's like, what do people want in the industry?
Okay. Excellent. Excellent. And we'll talk about that because I suspect a number of you. Yeah. What do you have?
I didn't explicitly study software, so I want to see what the packages of this are.
Okay.
I've done 10 years as an assistant admin.
Okay.
Trying to see like what can like transfer over.
So we have a whole wide range of people who, it's really amazing to me over the past 5 or 6 years how many people are transferring from doing something else and getting into software development. A lot of career changers. Last time I was in here, last time I gave this talk, one of the people had done mainframe programming back in the 90s, stopped to have a kid, and was now getting back into the workforce and and of course I would think it's 100% different. So if there are questions, if there's anything here that we can talk about, please, we don't have a time limit here, and I'm here to help you out. So please do. I've been doing software development professionally for 33 years, and I've managed, I've been a team leader, I've hired new programmers. I spend a lot of time on Stack Overflow. You may not know what Stack Overflow is. Okay. And so a lot of what I see is not even so much people on my team, but people who are asking questions in Stack Overflow, on various Reddits, and I keep seeing a lot of the same things over and over again. So I'm going to split this talk into 2 halves. There will be a halftime show. And first we're going to talk about technical stuff. And the second half we're going to talk about soft things. And the soft skills really aren't. But that's how we're going to split this up. So one of the first things that's important to me that people seem to get stuck on is that they can't live outside an IDE. Do most of us use Atom or VS Code or IntelliJ or something like that? Are you comfortable using the command line or using the shell? Can you do things like use Git from the shell and not relying on your IDE to do your commits for you? That's really important to be able to do, to understand the underlying things that are going on. Version control systems. How many people in school learn how to use a version control system? And it is amazing to me, as somebody who manages programs, that that's not a skill. That's not learned, because it's a key part of building software, of delivering software, of day-to-day life. So for those of us who do have jobs who didn't learn version control system, how did you learn? Did you just, on the job, seat of the pants, have to get told how to do it? Okay. So yeah, this is a big thing for me. A lot of what we're talking about in terms of tools are understanding the tools themselves and how to let the tools build and help you with your software. So one of the big things is that anything, will my little dot show up? It will not. Anything that we can do to have the compiler or our language environment help us out, help us find out about errors, is a win. These are just common examples, but every language has its own way of doing things. JavaScript has the use strict up at the top. PHP has error reporting levels. Learn to use those to let the computer do most of the work for you. There's an old adage that we should all remember, which is that people think computers work. And checking for syntax errors is one of the things computers do. And so if we can let the language environment do it for us, that's better. Static analysis tools. Static analysis tools are tools that look at the code that you have written and they analyze it without running it. That's the static and static analysis. And typically they'll be called something lint, like PyLint. The original static analysis tool for the C language was called lint, and it would because it would notionally pick out little pieces of lint out of your code, and it would find problems that you might not have recognized. Like, oh, here, you're using a variable before you've defined it. Or here, you're calling a function that you're not checking the return value of, and you really should be. So these kinds of static analysis tools are invaluable to your job, to you doing your job and building your software. And these are just some of them that I just Googled for them. There are a ton. And I'm assuming nobody in school ever got taught about anything like this. Okay. How many people are using them now? Okay, good.
Are these built into most IDEs? I've always had those kind of warnings.
Some IDEs will have them built in, or some IDEs will actually call the language or call an external tool, and as you go, they'll pop up and tell you, this is being called wrong, you're passing an integer, you should be passing a string, or something similar to that. Serious editing. Most of what we do as programmers, is not this. It's not the typing. That's the least of what we do, but we do a lot of it. And so being able to actually use your editor well, is an incredibly valuable skill. I don't care which of these tools you use, whether it's Vim or Emacs or Atom or Eclipse, although clearly Vim is God's chosen editor. I don't get what's funny about that. But not Notepad, not Notepad++. You need a programmer's editor, and you need to be comfortable with the programmer's editor because you're going to be using it all day. So get comfortable with using an editor, and so like not Pico or not Nano, because moving things around and even doing this is a way of programming. It's thinking about manipulating text and objects in the text. And it's another way of exercising your programming skills, even though you're just moving text around. This part, okay, make shell scripts and repeatability. Back to that rule about the computers are supposed to work so that we can think. And everything we do needs to be repeatable. Everything we do needs to not rely on us doing typing. So, for instance, if we are deploying software, we need to not do that by copying files out onto a server and manually starting up a server. We need to be able to push one button or run one script and have everything happen. We need to be able to run builds that take advantage of the scripting system or the shell that let you run things over and over again. Because not only one, the computers should be doing the work, but two, humans don't scale. And one of the reasons that humans don't scale is that humans make mistakes. This is another thing, this really ought to be a slide of its own. You are human. You will make mistakes. Anybody here who hasn't made a mistake? Right? And it's not your last one, and you're going to make mistakes. And everything you do when you're programming needs to reflect that expectation that you are going to make a mistake. And if it's not you, it's going to be you, or you, or you, whether it's a user, or another programmer, or who knows what. And so that idea of that you are human is something you always have to keep running in the back of your head. This also means you don't have to know everything. But we'll talk about that a little later too. HTML and CSS. Now we're getting into specifics. I don't think that everybody needs to know exactly how to make rounded corners in CSS. But basically, this is the lingua franca of everything. Everything we do these days is in HTML. And we need to be able to speak HTML. And that means we need to be able to understand the differences between physical markup and logical markup. So here, in physical markup, we're talking about, okay, well, we want to make this customer's bold, and we want to make this italic. When actually what we want is we want a heading here, and we need a paragraph here, and then we need emphasis on this. And part of that is not just because it makes it easier to change in the future, and it does, certainly, but part of that also is that it changes how you think about the program. It changes how you write about, how you think about writing the code that you need to write. So you need to think in terms of logical semantic blocks and not just the presentation of exactly how the pixels show up on the screen. Any questions, comments so far? Anybody learn HTML in school? Okay. What did they do? Did they talk about the differences between semantic and physical markup? I see some vigorous head shaking.
Honestly, the most I learned was here's Dreamweaver, try and make something that doesn't look like crap.
So basically treating Dreamweaver like a Word document.
Pretty much.
Yes? What were you gonna say?
I actually was taught only with semantic markup.
Okay.
So, like, the main class I took for HTML was online through a book, and it was teaching semantic markup through that. I didn't learn a lot about physical markup.
Okay. Okay, well, that's great. Can you tell me how long ago that was?
How what?
How long ago that was? Last year, 10 years ago?
Yeah, last year.
Okay, okay. So things are coming along where we are getting more and more into semantic markup physically. Okay, SQL. How many people know SQL? How many people learned it on the job? It is amazing to me that SQL is not taught in schools. There's a quote that I got from somebody after I gave this talk before. Everything uses a database. And for the most part, people are still using SQL databases. Yes, you'll sit here and make calls to Mongo or whatever the NoSQL flavor of the day is. But ultimately, if you're talking about big companies, they have big amounts of data, and they want to correlate a lot of data that is interrelated. And so the relational databases and being able to deal with the algebra of joining tables together is a crucial part of how we think about data. You can't make useful table layouts even, and you can't normalize your tables correctly without understanding SQL instinctively. Anybody not know what I mean by normalizing tables? Okay, normalizing table is, if you think about how people keep things, like you have somebody who's making an ad hoc database out of an Excel spreadsheet. And so they keep, so here's information, and there's repeated information in each row. That's kind of like if you had everything in one table in a single database. Whereas if you had it normalized, and you said, okay, well, this applies to this customer, and you have a customer ID, and the customer information is in another table, that's normalized. And there's second normalized form, and third and fourth normalized form, and I don't even know the definitions of them. Because realistically, except in an academic sense, going that far down doesn't matter. But the key is that we need to understand the relationship of the data that we have. The other reason that SQL is important, if we have, it is because it's a different way of thinking about the code that we have to do. SQL is an imperative language. Am I right? Is that imperative? Getting it wrong? So if we're sitting here, if we're going to go give everybody a raise, here's some pseudocode that's probably valid in some language or another. So we sit here and we loop through and we say, okay, the employee is not a manager that we're going to give them, we're going to update their salary by 10% and we're going to write it out. That makes perfect sense, right? You may not follow that. But that's not how SQL works. SQL works like this. SQL doesn't, in SQL, you don't tell how you're going to update the data. You don't tell the database how you're going to operate, how it should operate on the data. You just say, look, I'm just going to update the employees and I'm going to set their salary to this multiplier and I'm going to do it if they're not managers. And that is a different way of thinking about the problem that you're addressing. One of the great things that we can do as programmers to keep our skills sharp down the road is by learning new languages. Even if we don't actually use them day to day, learning a new language, and books like 7 Languages in 7 Weeks are good examples of that. But it teaches you new ways to think about things. And being able to write SQL like this is a different way of approaching problems than this example, than this brute force example that is sort of a naive implementation. Questions? Anything? Okay.
Why do you call it naive, or is it just naive in regards to SQL?
It's naive in the sense of it's the simplest thing that could possibly work. It's like, look, I just want to walk through it, and I'm going to look at each one, and I'm going to update it. And it's not naive in the sense, like, not like stupid, but it's just very simple.
There's better ways to do it, basically.
Yeah, and more idiomatic ways to do it. So it's a different mindset. Plus, it's faster to do it, to let SQL do it for you, because that's its job. Another one, regular expressions. Who here fears and loathes regular expressions? Who here knows regular expressions? Who here has no idea what regular expressions are? Okay. A regular expression is a way of defining a pattern that matches elements in a string. And it's kind of like file name logging in the shell. So if you say, foo.star, you know that means every file name that starts with foo dot and ends with something else. That's a very simple way of doing pattern matching. And regular expressions are a much greater, much more powerful way to do that. And they underlie a lot of Unix culture. So our 2 big needs for doing regular expressions are invalidating data and when we're searching our source code. Because presumably, the source code that we're working on is bigger than we can handle in our brains all at once. So being able to search is an important skill to have. So for instance, regular expressions are useful in cases like this. Say I have a part number, right? I'm in the warehouse, I'm doing data entry, and I want a part number that has 4 alpha characters and a hyphen and 2 digits. So you could write code that does that. You could write code like this, where we say, okay, well, I'm going to assume it's okay, and then I'm going to go through the first 4 character positions, and if it's not alphanumeric, or if it's not an alpha, I'm going to say it's no longer okay. And then I'm going to make sure that this character is a minus, and then I'm going to make sure that the last 2 characters are digits. That makes sense, right? And that works. And if you did that, you would put that in a function, right? Is valid part number, so that you wouldn't have to write it over and over again. But this is a pretty rough way to do this if you have regular expressions at your disposal. Because with a regular expression, you can write it like this, which means I'm looking for a start of a string, and then I'm looking for an uppercase letter from A to Z, and I need 4 of them in a row, and then I need a hyphen, and then I need a digit, and I need 2 of those, and then there better not be anything else because the dollar is the end of the string. This is a much, much easier way to write this. Now, guess up. Who sees this and goes, ugh? I understand that. I understand that, and that's a common thing. I see so many questions on Stack Overflow where people are saying, I don't understand regular expressions. I need a regular expression that checks this, and that looks for this in a string, that validates this, and they just can't figure it out. And part of it is, yeah, this syntax is kind of weird, and there's a lot of punctuation. But I mean, this is common. The ability to do regular expression matching is very common. Perl does it, PHP does it, Python does it, JavaScript has it, and every language has, if not matching regular expressions as part of the base language, at least a library, like in Python, that does it. And they're incredibly powerful for so many of the jobs that we just saw. Because this is really brutal. So people say, who can read that? I suggest that if you can read this, you can read this. How many people came out of the womb understanding what this line of code does? But you learn that this means, look, I'm going to assign this to the variable f, and I'm going to do 9 times 5 and times c, and blah, blah, blah. And in fact, I didn't even have to tell you what that is, right? What does that do? Right. You just saw it, and you immediately knew what it was, but you didn't know that before you started being a programmer. So I suggest that learning regular expressions will help you be a better programmer. You can make regular expressions a lot easier to read by putting in white space and comments. So here's the regular expression I wrote, and here it is. I've thrown in some white space to make it easier to read, to break things apart. I put this little X after it to say it's extended so that it will accept white space. I can even write it this way with actual comments. And if you're really paranoid about counting cycles and making things happen exactly as fast as you can, regular expressions are going to be faster than the way you wrote that loopy version anyway. So, a lot of people, hey, making fun of regular expressions online is kind of like stand-up comics doing bits about 7-Eleven or airline food or whatever, because they go, oh, regular expressions, this regular expression validates an email address according to RFC 2822. And it's terrible and unreadable. But part of the problem is that that's not a good job for a regular expression. There are some jobs that regular expressions are not good at. Things like, well, in this case, validating email addresses, validating HTML or XML, or parsing XML, or JSON, or anything like that, for two reasons. One, because they're not really regular in the mathematical sense, but two, there are libraries that do that for you anyway. If you are working with a programming language more modern than, say, COBOL, there's going to be code, there's going to be existing code that parses your XML, that parses your JSON. And so many times I see people, again, on Stack Overflow, who say, hey, here I have some JSON, I'm trying to parse it out with a regular expression, it's not working. And the answer is, don't do it that way. Guy I know talks about how, calls it stirring the paint can with the screwdriver. Because that's the thing that you have handy right there at the time. And so you gotta stir the paint, and it's not the right way to do it, but it leaves you with a ruined screwdriver. But it got you through it. So you knowing when to use regular expressions is part of this as well. The other big thing is searching for text. So if I'm searching my source code and I'm looking for these 4 functions, any instances of those 4 functions, because I want to modify these functions, and I want to make sure that nobody's called. I want to check every instance where they're called in the source code, so I can go search for those. So what would you do anyway if you're going to go look for it? Yes.
Underscore user underscore, assuming there's nothing else in that.
Okay, so you're suggesting that we could just search for underscore user underscore, but that might get you more than you actually want. Anybody else? Yes?
So to expand on that one, and at the beginning, we could have set or get, which would just be an S or G, ET.
Right, right, and so that's what we're going to do. So you could, really, the brute force way to do this is to search for the first string, and then search for the second one, and then search for the third, and then the fourth. Or we can do it, so if we were doing something like we were using grep from the command line, we would do it like that. We would say, fine, I want to use grep to go and search recursively through my directory for this string starting at this point. We all know grep. Anybody not know what grep is? Okay. The people who don't know what grep is, do you work at the Linux shell? Okay. So the Linux shell, grep is a standard Unix Linux tool that searches for text in the file system. So here it would say, look, just go and search all the files underneath my current directory for this string, and it will show you those results. So this is still the brute force way to do it, right? I'm doing that search on all 4 strings.
What's the value of making it recursive here? Does grep not search each file in its entirety?
Grep requires you to give it a list of files to search. And in this case, what we're doing is we're saying, look, instead, search the current directory, and then I'm going to search recursively all the way down below. But here's a better way to do it with the regular expression. We can say, look, what I really want is get or set, and then underscore user underscore, and then ID or name. And that's a much easier way to do a search for that. You know, yes, it's more syntax, but that's part of learning regular expressions. This also makes it really easy if we want to add another function. We say, hey, look, I want ID, name, and I also want phone number. Okay, well, fine, I'll just go add a pipe and phone here, and it'll search the same functions. And that's much more extendable. And part of this also is thinking in terms of patterns, thinking in terms of optimizing your workflow, thinking about the easiest way to do something. How many people are like me, where you've got a bunch of stuff you're carrying in from the car, and you're figuring out the easiest, how can I get in the house and make the fewest trips, and then once you're in the house, carry the right number of things to the bedroom, and the kitchen, and the kids' room, and you're doing all this in your brain. That's what you want to be doing here. Because that's what programming is about, is solving the problem, and probably in the quickest way you can. So that thing that you do, and how many people have had your family members make fun of you for it, that's our job. That's what we're getting paid for. So keep at it, but keep doing this, and this is a great way to optimize that. Now, if you are a grep user, there's another tool that you can use called App that is basically an optimized version of grep that is optimized for programmers, that assumes that you want to search from your current directory, and assumes you want to do recursive, and it color codes your results, and it makes it all pretty to see, and that will make your life happier. I wrote App, but I would recommend it even if I didn't. and actually, there are other tools like App that have taken off because of it. There's RibGrep, and there's AG, the Silver Searcher, and there are a bunch of other tools like that that are above and beyond existing Unix tools. And I just put up, actually, if you're scribbling stuff down, I just put up a website called altbox, ALTBOX.dev, which is alternative, it's like a toolbox of alternative Unix tools. And I would love it if people would contribute to it and tell me about tools that I don't know about. Just go and submit a GitHub issue about your favorite tool, and I'll put it on the website. Because there are so many of these tools that make life easier and make programming more fun. Your editor uses regular expressions. So even though my examples here are from the Unix command line, here's somebody in Atom. Well, they're using regular expressions for doing searching. Everybody uses regular expressions. And some editors, like Adam here, will even help you write the regular expressions. We'll sit here and draw these little syntax charts so you know exactly what you're searching for. They're incredibly powerful. And once you get past the then it will be a huge help in your toolbox. And just like with SQL, thinking in terms of regular expressions is a different mindset than this. Because here, you're not telling it how to match this, you're just saying, this is what I want it to match. Anybody got anything with, say, Elixir, the language? That Elixir gets into pattern matches, where you can sit here, how you call the function in Elixir, the language figures out how you're calling it, and based on the pattern of parameters that you're sending. So pattern matching is just more and more important every day. Anything else? Any questions on this point? Okay. Well, it is happening. That's my daughter on trumpet back there. That's my baby girl. Okay. Anything else tool-wise or hard tech-wise that we haven't covered that you think we might want to talk about? Okay, then I'm going to keep going. So now let's talk about concepts. concepts and soft skills. Somebody asked, what is it that programmers, or what is it that people are looking for? And this summarizes everything. 100%. And this goes into, even a job interview. When you're going for a job interview, you're not, yes, you can tell them what I know about it, and God, I know SQL, but what you really want to do is you want to show how to solve problems. Because that is what they're hiring for. The only reason they're hiring people is because they have problems that need to be solved. And so that's what they want you to do. So part of that is debugging. How were you taught about debugging in school? Anybody? I'm sorry? Jasmine? Oh, that's a debugger? And you would step through the code? Oh, wow, excellent.
We often just use debug, like, if this isn't working, start here. Is this working? Next one.
You would just put print statements in?
Yeah.
Okay, but you were actually taught how to do that. You were actually taught how, okay, that's good, because I also know a lot about where, it's not until you have a non-working program and you go to a TA and say, how do I solve this problem? But actually going through debugging, understanding how to debug code, that stepwise refinement is another crucial skill, yes?
So I go to Calvin, and in the second CS class that you typically take, that's when you get into, like, one of the labs a little bit later says, hey, here's how to use the debugger, and it clips, like, kind of runs you through some of those things, and also has you write your own test methods for some things, which is pretty nice. But then in most of the later courses, you don't really go over debugging at all. It's just kind of assumed that students know it. So when I help people as a lab assistant or any of that kind of stuff, a lot of times you're like, okay, now is a great time to use the debugger.
Right. And really the debugger is just a shortcut for print statements. Right? It's just a shortcut way of letting you step through the code without knowing in advance, I want to stop here, I want to stop here. But the process of debugging is not just, somebody calls you up and says, hey, my computer's not working, right? Like any relative. It's like, oh, well, the internet's broken. Well, I don't know what that means. Well, I click on the thing and it doesn't work. And you sit there and you're stepping through and that's debugging. That's debugging. Yes, turning it off and turning it on is not debugging. But figuring that out and thinking in the way that we think about these problems that non-programmers don't is a crucial part of what we need to do. And that's a valuable skill. And we sit here and narrow it down. So whether it's Uncle Bob's internet or whether it's, memory allocation error or whatever, it's all the same thing. Defensive programming. Calling back to the idea of we are all humans. If, you sit here and say, okay, well, we need to check for the case where this happens. And somebody goes, oh, we don't need to do that because that can never happen. Okay, except that, what do we do when it does? And you need to allow for that. And you need to have that mindset. So back to what you're taught in school, did anybody actually get taught this kind of mindset? Okay.
Maybe.
Actually, this is a complaint. My husband's a quality engineer.
Right.
He's like, they don't test to failing or they test to pass.
Right. She said they don't test to failing or they test to pass. And more these days, unit testing is a key part of the software development lifecycle. And you don't just write tests that verify that the function gives you the right output, but you also say, hey, what happens if I pass a negative number to my square root function? Should it crash? Should it do this? Doesn't matter what it is, but you need to know what it is and then test for it appropriately, yes?
Generally, in my coding classes, I've been taught, within reason, account for memory leaks. Like, if it's going to run for 5 minutes, you don't need to worry about ever hitting the end of a long integer, for example. But,
Oh, that makes me cry.
but for something like try catches your friend, basically,
Right.
for negatives or characters, or if it doesn't parse or whatever, that's also a great way for debugging. Just, why did this break? Start listing out or start spitting back out the errors that it threw.
But we need to start, we need to think in terms of this. We need to think, what happens if I pass a negative number to the square root function? What happens if I pass the user's address to the square root function? What will I do? All these things that can't go wrong will anyway, because humans are humans. Okay? The extension of that is testing. Okay, those of you who are employed, how many are, okay, hands up if you're employed as a programmer. Keep them up if you have unit testing as part of your software lifecycle. Okay, so about half the hands went down. And that's better than I think I would have gotten 10 years ago. Unit testing is more and more common and more the standard way of doing things these days, as it should be. And so you sit here and you write programs that actually run your programs or run parts of your programs. You write a program that calls the square root function with this set of data, and this set of data, and this set of data, and make sure that it operates correctly. And then you run that test every hour, or however often, or every time somebody makes a commit to the code base. That sort of continual checking of your code base is a crucial part of the software development lifecycle. That also means that you have your unit tests watching out for you. So if I go and change a function over here that has an unintended consequence over here, one hopes that the unit test over here that's testing this code will catch the fact that I broke it by changing this over here. And I'm assuming we've all gone through that problem where something over here got changed and this got broken because of it. And unit testing helps with that because, again, humans don't scale. DRY, who's heard of this? Oh, that makes me happy. DRY, as far as I know, came from the pragmatic programmer. That's don't repeat yourself. That means don't cut and paste code. If you have a chunk of code here that works and you need it over here as well, don't take it and put it over here. You're going to take it, put it over here in a function, and call it twice. You're not going to do the same calculations in two different places because one of them will change and then you'll be sad. Or you'll get a phone call into a new one. Or whatever bad things happen. Over time, I hope that we've all developed a healthy bit of fear of what the problems that our bugs can cause. I don't know that I would have the strength of will to work at a bank or to write embedded software for a heart monitor or something like that. Because that's got to be really scary. But those phone calls at 2 in the morning are no fun either. So anyway, DRY also is about not doing more work than you need to. For instance, remember we had those 4 functions we were searching for? And we were doing basically the same thing 4 times for 4 similar functions? Well, that's repeating myself. I just changed it a little bit. Oh, I forgot this slide was here. Okay. So y'all can read that. Efficiency. Another favorite topic on Stack Overflow. People will say, well, is it faster if I search a string this way or if I search it this way? And I suggest that most of the time it doesn't matter. And that it doesn't matter how fast your code runs if it runs incorrectly. And so speed of your code should be the very last thing on your mind. And sometimes people will say, well, what if you're Google? And okay, but you're not a Google. Anybody here work at Google? Okay. So put that out of your mind most of the time. Also, there's different kinds of efficiency. Are you talking about how fast things run, how much memory it uses? Everything's trade-offs. When you're actually, if you actually do have code that's too slow, you need to know why it's slow. You know, and can we trade off some memory usage in order to make things faster? Thinking business. Everything we do in our employment is to make money for the company. That's why they're paying us. Now, that making money might be in terms of saving time, and might not just be incoming sales, but whatever it is, even if you're working for a nonprofit, we are there to make money in some form, to help the company do something. And this informs a lot of what you need to think this way in terms of talking to other people in the company, especially your boss. Because your boss has problems, and your boss wants those problems solved. Because his boss is sitting here telling him he needs to fix this, and her boss is, it all rolls downhill. We're all there to make money. So we need to not go and say, hey, I think we should use Elixir as our new language. And you're, well, why? Well, because it looks fun. Well, okay, but that doesn't make us money. So I see questions like this all the time. How do I get my boss to use language X? Well, show up how it will make money. How do I get a second monitor? Show how it will make money. Is it going to make you write code better? Then you talk about that. Then you explain that. How do I get us to migrate to the cloud? All of these things have to have dollars and cents. And you talk about it in terms of dollars and hours, or dollars and weeks, or whatever the currency is. And I understand that this isn't really a computer science thing. It's more of a business mind thing. But it's still important for you in your careers. Working with existing code. When we sit here and we go to school, everything we write, right? Here's assignment 6. Modify this data file to do yada, 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 yada. But when you get out in the real world, that's going to be your first project. The first thing you're going to do when you get hired is they're going to sit you down and say, here's a ticket that we want you to go find the bug in. It is very rare that you will write code on your own with no one else on brand new code that doesn't exist. So you need to be able to work with other people's code. I would love it if schools did something like this. You say, okay, assignment 5 is we're going to write the code that does a thing. And assignment 6 is that we're going to do code review on somebody else's assignment 5. Anybody had to do that at school? How many people do code review as part of their software lifecycle now? Oh, I wish there were more hands. And if you badmouth somebody else's code, you fail. Because if you badmouth somebody else's code at the office, you're going to fail at the office real quick. Then assignment 7 will be extending the code, the other person's code that you looked at in the previous one, right? Because that's what real life is like. Great communications. Everybody is remote. Everybody is going remote these days. The world is living off of Slack and email. Sorry, this is the old slide. How many people were about to correct me on that? But we're communicating remotely. How many people are working remote? Anybody? How many people have remote people on their teams? Okay, right? I've got Tim in Denver. And he's the one guy on the team that is in the office with us. And so everything we do with him is written. It's in email, it's in the ticketing system, it's in Slack. So being able to write clearly and well and know what it is you want to say and say it effectively is a crucial part of what we do, because that's what we do. Nobody works in a vacuum. Back when I was starting, back in the 80s, you would have one guy sitting in that little office writing all the code for the company. But those days are long gone. And I'm sorry? So, this kind of written communication is crucial. And I would love it if you had to take a business communication class as part of your CS degree. I think that would be fantastic. So, wrapping up, what can you do to fill in these gaps? How many of you watching this go, oh, geez, there are some things I need to learn here? Okay. First off, I consider these to be the 2 books that every programmer should read. And I wish they were used in every CS curriculum. They're both old, and it doesn't matter. Because the stuff that's in it, especially Code Complete, Code Complete's this thick, but it covers everything. It covers how to debug. It covers how to name a variable correctly. It covers all of these things. Pragmatic Programmer, which we have here, they just announced that there's going to be a 20th anniversary edition that's coming out, and I could not be happier for that. But both of those are fantastic books. The other thing you can do, that I'm a big proponent of, is working in open source. If you work on an open source project, if you contribute to an open source project, you will be working with a distributed team. You will be using source control. You will have to understand the entire project life cycle. You will have to write tests. You're going to have to do a lot of written communication. If you're hunting for a job and you're not having any luck, spend your time working on an open source project, because then you have code that you can show at an interview. You can go, you can say, hey, look here, not only can I talk big about, oh yes, I know these things, you can actually bring code in and say, here, look what I wrote. Because if you have 2 people come in for an interview and they have the same resume, and this person comes in with that resume, and this person comes in with that resume, and code that she has written, she wins, because she is at much lower risk, because I can see the work that she has done. Anything you can do in job hunting that shows the boss that you know what you're talking about, that you can prove what you're talking about, is a huge win. How are we on time?
Good.
Anybody want to run away yet? Because I could talk about this forever, but I have a story to tell. My friend Bill, since we're talking about job hunting, and I actually wrote a book on job hunting called Land the Tech Job You Love. It's about 10 years old now, but I like it. When we're working on starting the book, me and my friend Bill, who lives in St. Louis, he wound up not working on the book, but he told a story about how he was a consultant. He was working as a consultant, and he went to a potential client with the sales rep for the company. And they were talking about all the things that the company needed Bill to do to help out. You know, do we want to hire this guy as a consultant? And so they go in, and Bill and the sales rep are sitting here, and the head of the CTO is complaining about, well, the network is slow right after lunch, and we have this problem with data and blah, 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 blah. And Bill goes, well, can I write up here on the whiteboard for me? And Bill gets up, and he says, okay, well, now, what I'm understanding is that your data flow looks like this, and your network looks like this, and he writes it out on the whiteboard. And then he says, so what I would do, if I came in here, what I would do is, I would change it so that it looks like this. And he starts writing it out and showing how the data flow would change. And CTO is going, oh my God, this is great. Runs out of the room, goes and gets his software development manager. And they're saying, oh, look at this, look at this. And they're very excited about it, and they start writing stuff down. And they're asking Bill questions about it. And his sales rep goes and starts erasing the whiteboard. And the CTO goes, no, wait, what are you doing? We need that. And he says, no, you need Bill. That's what you want to do in a job interview. You may not have that example to be able to do on the whiteboard, but you want to be able to show that you can solve their problems. In this case, Bill knew what the problems were because they told him. And he says, okay, well, here's what I would do. But before you go on a job interview, you can get an idea of what the problems are that the company wants to solve. Even if it's just knowing if say they're asking for Oracle and Mongo and some certain stack of technologies, you can go in there prepared to talk about how you can use those things and talk about how you have used them in the past to help them solve their problems. If you can find out what the company does and what kinds of problems they might be having, then you can go in being prepared to say, hey, you know what, I understand that you are moving to a second office and you're looking to expand your software development team. And so I have experience with that, and I've done whatever. But that goes back to thinking about business, thinking in terms of solving problems, bringing more knowledge to bear to doing what it is that the company needs you to do. And working in open, just to bring this back around, working in open source lets you do that. Oh, look, I have worked on this project that you use as part of your infrastructure. Yes, I am good at tuning Redis. I am good at, I do understand how the Postgres log system works. And you can show that. Because being able to show that is huge. You want them to say, no, we want Bill. So I believe we are at the end. Thank you for listening, and I will take any other questions.